the dot product. I'm going to give you two vectors, and we want to find u dot u dot v, and say the length of u squared. And vector u is 2, 3, and vector v is 5, negative 1. U dot v. You multiply the first components, you multiply the second components, and you add them up. This becomes 10 minus 3, which is 7. And u dot v is 7. What's u dot u? Well, u is 2, 3, and u is 2, 3. U dot u, you multiply the first components, you multiply the second components, you add them up. That's 13. So, u dot v is 13. U dot, oh, I did them in reverse order, recall. U dot v is 7. U dot u, 13. Now, if you look at u dot u for a moment, if you look at the lengths of u, wouldn't you do 2 squared plus 3 squared? I mean, 2 times 2, that's 2 squared, plus 3 times 3, that's 3 squared. That's what we've done to get u dot u. The only difference is you have to take the square root of it. But now, if you square the left side, I'm only squaring it because they asked me to square it. This is the square of 13. If you square the left side, you have to square the right side. It's always going to be the case that u dot u gives you the length of u squared. So, if they tell you the length of w is 113, and they ask you what's w dot w, well, you know that the length of w squared is 113 squared, which you're on your own with for that one. Okay, w dot w is just the length of w squared. So in fact, remember, this is the length of w squared. If I take the square root of the right side, I don't have to write square. Take the square root of the left side. The square root of w dot w is the length of w. Work it out. Convince yourself of that. And have fun with this stuff. If u is just a AB, well then the length of u will be a squared plus b squared square root. I square the right side, no square root. Then I have to square the left side. Okay? U equals AB. So therefore u dot u would be a times a, which is a squared, plus multiply the second values, b times b. I'm getting the same answer. That is u dot v, u dot itself is the length of u squared. Any vector dotted with itself will give you the length squared. You no longer have to use the formula to find the length of a vector. Just, it's kind of the same what I'm about to say. But you just dot the vector with itself and take square root. It's exactly the same. Okay, and we did all three of them. Good. Find the angle between the two vectors. Now, we have this alternative formula to find u dot v. It's the length of u times the length of v times the cosine of the angle between u and v. Sometimes, if it's not clear what angle you mean, they put u comma v next to the angle. Okay, so it's clear as can be, that the angle we're talking about is the angle between u and v. Well, if you divide both sides by the product of their lengths, what you get is that u dot v divided by the length of u times the length of v. This is the cosine of the angle. Okay, now, so this is kind of the formula we're going to use. If I tell you that u is 1, 1, and v is 2, negative 2. So, the cosine of the angle is u dot v. You multiply the x values, you multiply the second values, and you add them up, and you get 0. That's u dot v. It's 0. And the length of u is 1 squared plus 1 squared. 1 squared plus 1 squared is square root of 2. So the square root of 1 squared plus 1 squared. The length is going to be 2 squared plus negative 2 squared square root. It's the square root of 8. 2 times 8 is 16, so you have the square root of 16, which is 4. 0 divided by 4 is 0. The cosine of the cosine of theta is 0. Cosine of theta is 0 and 90 degrees. So, pi over 2. The angle between u and v is 90 degrees. Okay, that's the formula that's boxed that you use. I want to draw this so you can actually see that it's true. Maybe I'm making it up. Maybe I'm wrong. 1, 1 is right here. That's vector u. Vector v is 2, negative 2. It's right here. It's that vector. And my scale's off a little bit, but that's 90 degrees. That's 90 degrees. And 2, negative 2 crosses 1, negative 1. It's a right angle. Okay, and I know it is because the mathematics show that. Two vectors meet at a right angle. They're said to be orthogonal. But actually, real quickly, we just learned the test to tell if two angles are orthogonal to one another. Okay, if the dot product is 0, assuming that u and v are not the 0 vector, that is, the length of u is not 0 and the length of v is not 0. If u dot v is 0, then 0 divided by not 0 is 0. The cosine of 0 is 0. That implies that the angle is 90 degrees, the angle between the two vectors. Okay, if u dot v is 0 and the vectors are not 0, okay, if the length of u, if the length of AB, which is a squared plus b squared square root, if it's 0, that means a squared plus b squared was 0. If you square stuff and you add them up and you got 0, you must have been squaring 0. That is, AB was 0. AB was 0. And I'm saying if it's not that, but yet you get 0 and yet the numerator u dot v is 0, that means the vectors are meeting at right angles. 90 degree is right angles. If the dot product is 0, then the vectors are meeting at right angles. They're said to be orthogonal. 2, negative 3, negative 9, 6. 2, negative 3, negative 9, 6. That's v. That's u. So the cosine of the angle is u dot v divided by the length of u times the length of v. U dot v. You multiply, you get negative 18 plus, you multiply, get negative 18. That happens to be negative 36. Okay, now the length of u is 2 squared plus negative 3 squared. Happens to be the square root of 13. And the length of v is negative 9 squared plus 6 squared, 110, 117. $117 times 13 is 51, 351, and 117 is 1521. So, how you would define the angle is as follows. The cosine of this angle is negative 36 divided by this. Now, I believe answers should be exact. I believe that answers should be exact. So the exact answer is the cosine inverse of negative 36 over the square root of 1521. You want to use your calculator and get an approximation, go for it. Me, I want the exact answer. Okay, then that would be the exact answer. So sometimes you know the cosine, what the cosine of theta equals, and because of your vast knowledge of trigonometry, you can rattle off what that angle is. Other times it's an unusual angle, in which case you use inverse trig functions. Now, here they're asking us to find the angle to give us a vector, say 1, 3, say 1 square root of 3. They give you that vector. And let me draw it and then I can say more clearly what they're asking. 1 square root of 3. Let me put 1 here, sorry. Here's the vector. That's the vector. That's vector u. And what they're asking is, what is the angle off the positive x-axis? What's that angle? Well, you know that this is square root of 3 and this is 1. So, actually, you should recognize this as a special right triangle where this angle is 60 degrees. That is pi over 3. Or you can say the tangent of the angle is square root of 3 over 1, which is square root of 3. And the angle is the tan inverse of the square root of 3. In this case, if this is what you wrote on an exam I gave you, I would then ask you, and what does that equal, and take off some points. Because you're supposed to know the tangent of one angle gives you square root of 3. The answer is pi over 3. Okay, you're supposed to recognize that. If it wasn't one of the ones you would recognize, saying something equivalent to the tan inverse of square root of 3 would have been fine. You can even talk about arc cosines, or cosine inverse, or sine inverses, or tan inverse, whatever you prefer. If they tell you that u is 1i minus 1j, that just means 1, negative 1. The number of i's, the number of j's. If you have ai plus bj, this is a, b. Okay, so you have 1, negative 1. 1, negative 1. Right here. The question is, find the positive angle, theta, between a given vector and the positive x-axis. So we want to know that angle. Well, we know this is 1 and negative 1, and that's 1. But we know that angle. Let me just draw it bigger. We know that triangle. 1 and 1, that means this is 45 degrees. The angle is 45 degrees. It says, find the positive angle between the vector and the positive x-axis. This is the positive x-axis. They want to know this angle. I don't care that it's negative, going backwards. The angle is 45 degrees. Okay, we could use the formula. We can use the formula and kind of get the same answer, and then say, oh, they asked for the positive answer. Now remember, the positive x-axis, well, you can, doesn't matter how long it is, it's 50. That's v. V is 50 or 50, it doesn't matter. And u is 1, negative 1. So u dot v would be 5, just 5. 5 times 1 is 5. 0 times negative 1 is 0. You add them up, you get 5. And then we divide by the length of u, which is 5. Think about it. And the length of, that's the length of v, excuse me. Times the length of u, if you think about it as well, it's the square root of 2. So we get 1 over square root of 2. That's the cosine of theta. That's the cosine of theta. The cosine of theta is 1 over square root of 2. 1 over the square root of 2. So then this, what's bothering me is, that's 1, excuse me. So this angle is 45 degrees. 1 square root of 2 is 45 degrees. Exactly what we got before. You're able to pick any vector on the x-axis. Any vector. Now, the reason is as follows. If this theory is working, here's the reason. Here's one vector, here's another vector. And the formula, and here's an angle between them. The formula says that the cosine of that angle, this is u and that's v. The cosine of that angle is u dot v divided by the length of u times the length of v. It is that. Now you know what? If I make this longer, isn't the angle still the same? If I make the length of u shorter, isn't the angle in between still the same? It's not going to matter. The reason it doesn't matter is because that length is always 1. We talked about that. If you take a vector and you divide it by the length, it becomes length 1. So it doesn't matter if I make v longer, because if v becomes longer, then the length of v becomes longer, and when you divide the two, what you always have to do, the length is 1 anyway. So, if you want to know the angle between this vector and the positive x-axis, you can take this portion of the positive x-axis of your vector, or you can take a longer vector or a shorter vector. Your choice. Just don't pick a vector of length 0. Don't pick 0, 0. Pick 2, 0, 5, 0. Determine whether the vectors u and v are orthogonal, parallel, or neither. Orthogonal, parallel, or neither. Well, two vectors are parallel if the angle between them is 0, or the angle between them is 180 degrees. This is parallel. Okay, that's parallel. If you have this vector going that way, and you have another vector right on top of it going that way, when you put them head to tail, they're still parallel, but the angle is 180 degrees. So if the angle is 0 or 180 degrees, they're parallel. If the perpendicular implies the angle between them must be 90 degrees. All right. Now, let's see what happens here. Let's see what happens. Let's suppose the angle is 0. So the cosine of 0, which is 1, is equal to u dot v divided by the length of u times the length of v. That's one way. Okay, that is, you actually have to do the calculation. You have to do the calculation. If the angle is pi, so you have to do this calculation and get 1. And say parallel, the angle is pi, the cosine of pi is negative 1. And that equals u dot v divided by this mess. If you compute the right-hand side of that formula, and you get negative 1, you say parallel. Perpendicular is more friendly, because if the angle is pi over 2, the cosine of pi over 2 is 0. Yep, I need to erase this. The cosine of pi over 2 happens to be 0. And when a fraction equals 0, that implies the numerator is 0. And this is assuming, we're assuming the length of u is not 0 and the length of v is not 0. Assuming that, if you compute this, if you just compute the dot product and you get 0, that means this fraction will be 0. If the numerator is 0 and the bottom is not, and if this assumption is true, the bottom won't be 0, then you do get 0. And that means the angle was positive. Okay, orthogonal means that you get plus minus 1. Parallel means you get 0. And neither means you don't get 0 and you don't get plus minus 1. So that's something that you have to know to walk around saying that. Two vectors are parallel if u dot v divided by the length of u times the length of v is plus or minus 1. It's parallel if it's 0, which means u dot v is 0. The numerator is 0. Okay, so I'll give you a couple of vectors and we'll decide if they're parallel or not. U is 4 is 0 and v is 1, 1. Now if you think about it, this is not going to be parallel because 4 is 0, the head is right here. That is, the vector goes this way. The only thing that's going to be parallel to that, now I do have one typo. These are the components. When you're told the components, they go like that. To be perpendicular, for example, if you're starting at 0, 0, you have to go straight up, which means you'll be in the form of 0, 4, 0, 5, 0, 2.5, 0 something. But it's not that. It's 1, 1. I mean, 1, 1 is right here. 1, 1. It's not going to be the case. Which is not friendly because that means you have a lot of work to do. Okay. U dot v is, you multiply, you get 4. You multiply, you get 0. You add them up, you get 4. Then you divide by the length of u times the length of v. The length of u is 4. The length of v is 1 squared plus 1 squared, which is 2, the square root of that. 4 times the square root of 2. So you get 1 over the square root of 2. This is not 0. This is not plus or minus 1. So the answer is neither. The vectors are neither parallel nor perpendicular. What about 2, negative 4, and 2, 1? U and V. First thing you should do is a dot product. If that's 0, you're done. That product is 4 plus that product is negative 4, it's 0. They're parallel. The only vector that starts at 0, 0 and has a length of 0 is the vector whose head ends at 0, 0. It starts at 0, 0 and ends at 0, 0. That is, it goes nowhere. Its length is 0. The length of u is not 0. It's just not 0, 0. The length of v is not 0, 0. So the length is not 0. If the lengths are not 0, but the dot product is 0, forget about it. Parallel. How might you think of one that is perpendicular? How about we do 1, 1? And over here we think negative 1, 1, but we can scale it. Negative 3, 3. Those are your two vectors. Negative 3, 3. And v is 1, 1. If you understood what I just did, fine. If you didn't, it doesn't matter. We're going to show that these are parallel. Excuse me, perpendicular. U dot v is negative 3 plus 3, which is 0, which means, I'm going to see something. Nope. I thought I did that. Not parallel. Oops, I have these backwards on top. It's perpendicular. I have the numbers on the top backwards. Sorry. For parallel, it should be plus minus 1. For orthogonal, that means perpendicular. For orthogonal, it should be 0. Perpendicular or orthogonal. So, in the problem we're doing now, since the dot product was 0, that means they are perpendicular. Orthogonal means perpendicular. Sorry about that. So, how can we get to vectors that are parallel? That's what I meant to say. Sorry. What you can do is write down a line that crosses the origin like y equals 3x and just pick 2 points. Here's the line y equals 3x. If I just find 2 points, like x is 2, y is 6, that vector and say the vector that has this tail, x is negative 1, y is 3. Those 2 vectors are going to be parallel. Those 2 vectors will be parallel. This is vector u, this is vector v. U dot v will be, well, 2 times negative 2 is negative 2 plus 6 times 3 is 18. That gives me 16. And I divide by the length of u, which is 4 plus 36, the square root of 40. Divide by the square root of 40. The length of v is, you square negative 1, you square 3, you get the square root of 10, which becomes the square root of 400, which is 20. 4 goes in here 4 times, 4 goes in there 5 times. Negative 3, negative 3, negative 3. Should be negative 3. Negative 2 plus negative 18. Negative 18, sorry. Negative 2 plus negative 18. negative 2 plus negative 18 is negative 20 over 20, which is negative 1, which implies parallel. Just take a line that crosses the origin and find 2 points on them. Here's a line that crosses the origin. At least I meant for it. If I take this point, whatever point that is, RS, that gives me the vector, RS. It gives me the vector that starts at the origin and goes to that point. If you take another point on the line, TU, well then this vector starting at the origin is TU. Just take 2 points on, find 2 points on the line and that crosses the origin. And they will give you a dot product. Excuse me, the cosine of angle will be plus or minus 1, which means the angles, which means the vectors are parallel. And the next one is to find the projection of U onto V. We'll work with the formula, but I just want to point out what exactly does that mean. So I'm going to show you what it means. Here is vector U. That's what I'm going to call that V. Here is vector U, and here is, on the bottom, vector V. The projection of U onto V. Go from U at a right angle to V. Right there. That's the projection of U onto V. What you should think, if you have a really shiny light, where along V, where would there be no light on V? I want to think a moment. Okay, I'm going to say it differently, because that's not working. Through V, draw a line parallel to V. Imagine we have light beams that go just straight down. But they can't go through V. They can't go, they can't go through U. Where would there be no light on V? And the answer is over here. That's the projection of U onto V. I mean, it's probably better to think of it as horizontally. Here's U, and here's V. The projection would be this portion. That would be the projection of U onto V. Now you may say, but wait a minute, what if U happens to be a lot longer? Well, you extend V. This would be the projection of U onto V. It would even be longer than V. How about that? Be longer than V. Now, the formula says the projection of U onto V is equal to U dot V divided by the length of V squared times the vector U. Okay, so give me 2 vectors, U and V, and we find the projection. Suppose U is 2, 3, u is 2, 3, and v is 5, 1. V is 5, 1. What is the projection of u onto v? Now, I do want to make one last comment. If here is v and this is u, the projection of u onto v is pod or v. It's either all of v, shorter than v, bigger than v. So it makes sense that it's some number times the vector v. Maybe it's 2 times v or half times v. But it does make sense that it's in the direction of v. Now, could it be in the direction of negative v? Sure. If this is v and this is u, like I said, you might have to extend v. The projection would be that. And you know, right here is the origin. That v goes that way. We're going, the projection goes in the opposite direction. That means it's going to be that number in front of v, the u dot v over the length of v squared, will be a negative number. Okay, let us find u dot v. U dot v, you multiply the first values, you multiply the second values, you add them up. Okay, so we get 13 divided by the length of v squared. The length of v squared is just 5 squared plus 1 squared, which is 25 plus 1, which is 26. Since it said square, I'm not taking the square root. So I divide by 26 times the vector u, which v, the vector v, excuse me, which is 5, 1. A little arithmetic tells me that's a half. So I take half of the 5, and I take half of the 1. And there it is. You actually just get half of it. Okay. So visually speaking, here is 2, 3. Right here is 2, 3. That is vector v. No, that's vector u. And 5, 1 is right here. That is vector v. The projection is this piece. And it does look like half of it. That's the projection. That vector. Okay, that vector is a projection. So you have a nice formula, and that's how you do this. You use that formula. Take the dot product, you divide it by v. What you're projecting onto goes in the bottom. These two should be the same vector. So how about u is equal to the square root of 3, 1? You should have those special brackets, I'm sorry. And v is negative the square root of 3, negative 1. So u dot v, well, when I multiply those two, I get 3. When I multiply those two, I get negative 1. When you add them up, I get 2. So I get 2 on the top, divided by the length of v squared. You square this, you get 3. You square that, you get 1. And if I don't take the square root, I get the length of v squared, which is 4, times v, which is negative the square root of 3, negative 1. That number again is a half. Don't think they're all a half. There it is. That's the vector. That's the projection of u onto v. Okay, that finishes this section entitled the dot product.